All right, so we're going to talk about how we can train the ARAS system, the ascending reticular activating system, and the ACC, the anterior cingulate cortex, and what those systems do. All right, let's get this. Starting off, and here are the terms. You can see them again. Sometimes the ARAS, that was the original name, has been called other things. One of the interesting summaries of mental health issues was done by Gray McNaughton. Gray's passed on. McNaughton, I think he's in New Zealand. He was doing EEG research at one time. I don't know about recently. How we can look at threats and divide them into these basic categories. So you have a potential threat, some sense of something's going to go wrong. You're going to be here in the age of COVID, it's about catching COVID, for instance, but there's other forms of threat, fears, various fears of robbery and injury and so forth and harm. And you also have actual threats, those that are facing you directly in front of you. So in the potential threats, you can first further divide them into detectable and undetectable. And the undetectable one, this is their model, which I do like, is that so when you have undetectable threat, and that would be COVID, greatly so, you're constantly anticipating, is the symptoms coming on? I got a sore throat, I got a little headache, I'm saying, oh, I had a little chill there, I shivered, do I have COVID now? And that constant anticipation, this is the clinical problem would be obsessions, and they argue that the cingulate was involved, and I would also say the anterior cingulate in particular. Also probably the amygdala, but the amygdala, we're going to wait for a little bit later to talk about that. Versus a detectable threat. Detectable threat would be, for instance, potential threat would be, walking down the dark alleyway at night, worrying that you're going to get robbed. And so either you can avoid doing that, and the argument would be that the septal hippocampus system gives you deals with the constantly accessing. Is the threat there present? Is the threat present, and leads to anxiety? Now here, that's the case where you don't have to go down that alleyway. But if you have to go down that alleyway, you have to go a long distance. You can't avoid this, or avoiding a bully in school, for instance. You're going to see him in third period, or something to that response would be, they say it's the noradrenaline in the serotonin system that's involved instead of a single brain region or brain areas, and it leads to depression. And this is a good description of depression, which is that when we're depressed, we conserve our resources. That's been understood for many years. So you see, when someone's depressed, they don't expand, they contract, they conserve. Okay, so there's potential threats, and then you have actual threats. And the actual threats, you have the avoidable ones. You can run away from them, and the unavoidable ones like you meet the bully and they're right in front of you. You can't get around them. So do you fight or freeze? Sometimes maybe it looks like you're faced with imminent danger, but there may be more targets than just you. And this is all done in the lower part of the brain. That's the lowest part of the brain, periaqueductal gray area. That's in the brainstem, upper brainstem. And this is the basic like fish response when a shark comes by or some looming threat. Freeze. Maybe they'll go for another target. But you could be that you're the only target available. Well, if you freeze, the panic system kicks in. That's in the left periaqueductal gray area. Over respond to the threat. Or you fight, and that he would say that he is the hypothalamus, medial hypothalamus of anger. Though anger, I believe, I put it more in the amygdala. And they have amygdala. I think the right amygdala is more the anger side, and left amygdala is more the fear side. So flee and fight, I would move over here. But it is an interesting model to think about mental health issues. Okay, so in that model was the cingulates, and specifically the anterior cingulate. And I've said in many of the videos and talks how we look at theta as three forms. We have neocortical theta, subcortical theta, and then this one in between, the cingulate theta, the anterior cingulate theta, what I call the problem-solving theta. So this being the more advanced or developed would be the neocortical. The subcortical is more primitive. It's me versus everyone else. This is more the group-minded one. This is the problem-solving in between. And years ago, people discerned that theta did not have a single generator when you were recording it from the scalp. It had multiple generators. Delta seemed to have one generator. Alpha seemed to have one generator. Beta seemed to have one generator in essence, but theta had multiple generators, and that's because there's multiple sources of theta. Okay, so, and some of the sources are here, like for instance, the hippocampus. This is a hippocampal cell over here, or at least a depiction of it. The amygdala right at the end there, and here's the anterior cingulate up in front. And the anterior cingulate has two sections. On top is the dorsal part, and then what they just say, anterior cingulate, the ventral part. This is the posterior cingulate, which we've talked about before. And I bring up this study by McNaughton here. And the argument, is the theta is very clearly in the hippocampus. There's all kinds of studies. There's journals called the hippocampus that talks about theta. Hundreds of thousands of papers on hippocampal theta. It's studied greatly in how it corresponds with movements in rats and spatial recognition and so forth. And it comes down to, okay, when we're looking at theta, is it coming out of the hippocampus? So this is a paper that was arguing frontal midline theta, when you see it, is not hippocampal. And what they show, one of the other characteristics of that theta is how it's associated with anxiety. And if you look through these ones, it's mostly about how anxiety, and the more frontal midline theta you have, the more power, more magnitude, or more activity incidence, you have less anxiety. Okay. So this is what I like to call the third form of theta. And I really kind of slow down alpha. In fact, I take this alpha rhythm and I pulled it wide, so it's pretty much going the same speed, almost same width of theta. But that's how I see the neocortical theta. You see this in the back of the head when the young kids, when they're showing what's essentially what's called the posterior dominant rhythm, what we call the alpha rhythm, but it's in the theta frequency range. So it's like 7 hertz or 6 hertz, and it's acting just like occipital alpha will in the adult. It's a slow thermocortical theta, thermocortical activity acting in the theta realm. And then you have all kinds of forms of subcortical theta, fornix, hypothalamus, other sources. And then you have this one that we're talking about right now. And this is the good theta. Typically we want depends what the person's doing, of course. If you're watching a movie and you're showing neocortical theta, that's sad. You want subcortical theta. You want to be emotionally involved. So you can think of this like emotion, and this is the more reasoning and planning systems. They're both going to be involved in like watching a movie, but the more engaged, you get more of this primitive systems engaging. You get more relational in your thinking. This is about me. The middle anterior cingulate theta it's very good in some. It's bad in certain cases. If your eyes are closed and you start showing that kind of theta in your anterior cingulate, which is that site FZ picks it up very strongly, it means what are you problem solving about? You can't even think, you can't even calm your mind for a moment when you're relaxing. That's not good theta. But when you're trying to solve problems, you want this theta to be activated. You want a lot of it. You want a high incidence, high magnitude. Okay, just quickly, some of the things unique about our ACC. You can see it's larger and anatomically differentiated in the primates, has unusually well-developed area 5 for connecting to others. And we have these spindle cells, these huge pyramidal neurons, and that's the anterior cingulate here. And this is probably the dorsal anterior cingulate. Not sure how they're drawing this. If that's good. Yeah. But we have much more than you can see our genetic brethren, nearby brethren. The gigantopyramidal neurons, that's for power gripping objects. Okay, so, and the spindle cell proliferation, I believe proliferance would be a word, but it wasn't in the dictionary, so I put in the word they said. Proliferation can be a source of clinical symptoms. That sometimes one of the arguments is that there's excessive survival of spindle cells, like alerting cells in a way. I like to call them town crier cells. They alert to the other systems to recruit their resources of what's going on, so they can be pulled into what's going on. They may contribute to some things such as the OCD. And again, during the COVID years, hopefully that's a misstatement. During this COVID period, we are obsessed with being actively vigilant and not making mistakes and letting COVID spread to us and our loved ones. Okay, going back to the ACC, They have these huge arborizations. These spindle cells scale with the large size of the head, allowing them to broadcast to numerous regions, as I was mentioning. And one thing that was always interesting years ago, people would say, "Oh, FC, that's the anterior cingulate." And I go, "Well, how can FC be the anterior cingulate when you have this cortical tissue in between?" Well, part of it is they have these huge spindle cells, so it can create the strong potentials that can emerge at the surface. And I'm showing you, this is a depiction of how we can see. There's a blue here is a reduction. This is an excessive. There is a fMRI image, I believe, could be PET, but by fMRI, of excessive frontal midline theta. Could be even a MEG image put on there, a magnetic encephalography. Okay, so something interesting about frontal midline theta. We do see this reduction of theta. This is a reasonable depiction in aging, how we have a loss of theta as we get older. So one of the things to do is just resupply that. That's what default network training, DNT, we resupply the alpha activity, give that the system more organized again, get it out of the chaos decline that can be experienced. And in theta, I don't want to include theta in most places, but in the anterior cingulate, I definitely want to increase it. And here's some of the issues you can see. So the frontal midline theta is reduced in anxiety and restored when anxiety is relieved. So that's good correspondence. And again, we don't have to use a drug for that. We can just use operant conditioning and condition the theta up at the anterior cingulate, at FC, and around FC. We have a site we call BA32, which is the dorsal AC site, dorsal anterior cingulate site, and it's right in front of FC. It's between AFC and FC. The ACC is involved in processing of pain, and there's a lot of things about removing pain through improving the ACC or even decorticating it at times when it's severe pain. Hyperactivity of the ACC is observed in depressed patients. Frontal midline theta exhibited great response for negative feedback over positive, so that just shows we looking for what's bad. So that's what partly the ACC is doing, is looking for consequences of actions and being more sensitive to the negative consequences or clues that this negativity could emerge from certain behaviors. The frontal midline theta reflects the contribution of ACC to cognitive control, memory processing, conflict processing, and sensitivity to punishment. And I got my little thing here. Increases in frontal midline theta improve behavioral performance generally in terms of executive functioning. Okay, let me go back to here now. Some clinical correlates. So the spindle cells are reduced in Alzheimer's. Reduced size of the ACC is a risk factor in the development of dementia in the elderly. The anterior cingulate is reduced in size of metabolic activity in autistics. Both the size and activity of the ventral part of the ACC are reduced in depression. Increased activity of the ventral ACC in OCD and phobias. You can read that right there. Okay, here's a nice statement. Large strokes involving ACC produce patients who lie in bed and say or do little. With strong arousal, they can move or speak a few words, revealing that they're not paralyzed. If the patient recovers, he or she reports feeling empty, having no will to say or do anything immediately following a stroke. That shows the involvement of ACC in our will. And increasing our will should in most cases be healthy. Not in those who are ODD, ODD is oppositional defiant or chronic disorder, but for everyone else, increasing our will is usually helpful, especially depressed individuals. Small lesions, ACC reduce anxiety. In fact, they'll do a cingulatotomy to scoop out the ACC when in extreme examples of severe pain at the end of life or near the end of life. But when we do that, you lesion the ACC, there's a reduction of our will, our response to generate responses to novel stimuli. Here's the ACC 24, and where's 32? That's the dorsal part of it. This is Vienna, Essen, and Drury has sort of peeled out, and this is unknown. Here's 32 right there. It shows the amount of tissue that it has. And here's a posterior cingulate. A posterior cingulate, I thought I had a section 23 around. But it is very small, very important, but small. Yeah, here's 23 as well. So that's the posterior and the anterior.